Hello, hello, hello. Can you listen me? Hello, hello, hello. हाँ, PC2. PC2 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ, ಗುರು ಹಿರಿಯರಿಗೆ, ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೇತ್ಸ್. Yes, good morning, my dear students. Let us continue the chapter solutions. In the last class, we started studying the second topic, that is solubility. Solubility. What all we learnt in the last chapter, solubility, is the amount of the solute dissolved. Every solvent will have certain ability to dissolve a particular solute in it. There are mainly two components in a solution we discussed: solute and the solvent. Solute and the solvent, when they react with each other, we take a solid solute, liquid solvent, and studied that there exists an equilibrium between them. Once a saturation is crossed, if the solvent is liquid, generally liquid will decide the state of the solution, and solute, when dissolved in solvent, solid solute when dissolved in liquid solvent, it will form a solution. It will be in equilibrium, and this particular process is called as the dissolution. Like sugar when dissolved in water, salt when dissolved in water. Whenever solid solute or dissolved in water, there is a certain stage. Before a stage is reached when it cannot dissolve any more solute in it, then we say that the solution is said to be saturated. After reaching saturation, the backward reaction starts. That is, the dissolved solute will after crossing the saturation stage, the solvent cannot dissolve any more solute in it. Then the reverse process, excess solute particles present in the solution will settle at the bottom. The process is called as crystallization. It is called as crystallization. And a stage is reached when this conversion of solute into means dissolution and crystallization, both of them will attain a state of equilibrium. Whenever equilibrium is attained, you can apply what? A principle called as Leach-Atlas principle. I think I cleared you in the previous class what is Le-Chatelier's principle. Simply speaking, every equilibrium system will try to maintain its state of equilibrium. Is a summary of industrial chemist Le-Chatelier. What he says is that every equilibrium system do not like to disturb from equilibrium state. It will continue to be in the state of equilibrium. Mainly there are two factors that affect this particular solubility of a particular solute in a solvent. Depends upon the nature of the solute, and temperature, pressure. In case of solid in a liquid solution, we studied 9 types of the solutions. In them we are considering particularly solid in liquid. What is the effect of temperature? Means generally some solute like sodium chloride, when dissolved in water, right? They are endothermic in nature. Endothermic means minus heat. Minus heat means heat energy will be absorbed, right? Therefore, excess heat must be subtracted from it. In equation we are writing. Means endothermic reactions. If a particular dissolution is endothermic, sodium chloride in water, aqueous solution of the sodium chloride you take, this will absorb heat energy. In that case, what is the effect of temperature? We discussed. As the temperature is increased, in order to attain the equilibrium back, endothermic reaction should take place. Therefore, the dissolution increases. Means forward reaction. Dissolution increases. If the dissolution of a salt in water is endothermic, the summary effect of temperature. Endothermic means heat energy is absorbed. Then to increase the solubility, what you have to do is, in order to increase the dissolution of the you have to increase the temperature. For example, if you take sodium hydroxide solution in water, we discussed that it is exothermic. Dissolution of sodium hydroxide in water is exothermic. Then what happens? Heat energy will be liberated to the surroundings. Then, in case of when temperature is decreased, backward reaction takes place. Means if the dissolution is endothermic, what is the effect of increase in temperature? Reaction shift to the forward direction. Forward direction means dissolution increases. If the temperature is decreased, in order to increase the reaction, means if the forward reaction is endothermic, so backward reaction will be exothermic. Therefore, crystallization will take place. Means backward reaction takes place in case of endothermic. This is a summary. If the dissolution of a particular solute is exothermic, means heat energy is liberated by increasing the temperature. In order to nullify the effect, forward reaction is exothermic, means backward reaction will be endothermic. Minus heat. Backward reaction will be endothermic. Therefore, in order to nullify the increase in the effect, if the dissolution is exothermic, then what happens? Backward reaction takes place. Crystallization will be favored. If the temperature is decreased, in order to increase the temperature, exothermic reaction takes place. Therefore, a dissolution will be affected. Means, summary is, the factor that favors the dissolution, if the reaction is endothermic, is increase in temperature. The factor that increases the dissolution, suppose that we want to increase the dissolution, then the temperature must be decreased. At lower temperature, if the reaction is exothermic, reaction will be, in order to increase the temperature, then reaction will take place, forward reaction. Means summary is, in order to increase the solubility of endothermic dissolution of sodium chloride, what you have to do is you have to increase the temperature. What is the condition favorable for the dissolution of sodium hydroxide is decrease in the temperature. Arrow mark down means temperature decreases, arrow mark up means temperature increases. This was the summary of what all we discussed in the previous class. Today we will continue with the second case. First case is solubility of a solid in liquid we studied, and effect of temperature. What is the effect of pressure? Generally in solids and liquids, pressure has no effect, we discussed. Let us take the second case today. Case 2. Case 2 is solubility of gas in liquid. Solubility of gas in liquid, right? We can take 2-3 examples here. If you take aquatic animals living under water, look at here. Suppose that this is the water body and aquatic animals are living in it. Aquatic animals living under like fish living underwater. Generally, the fish or any aquatic animals, atmospheric care will be there over it. Atmospheric care will have the pressure on it, right? This is a gas, air is a gas. What air consists of? Air consists of nitrogen and oxygen. Nitrogen, oxygen, all other gases will be present. Generally, at a given room temperature, what happens? Some amount of the oxygen in water, because atmospheric pressure is taken as 1 atmosphere. At 1 atmospheric pressure, whenever you take a gas, that is oxygen present in the air will be dissolved in some quantity. This particular dissolution is very less. And this solubility of a gas in a liquid, solubility of oxygen in water body is less. That little quantity of oxygen is sufficient for respiration of the aquatic animals, right? If it is a winter season is winter, then more oxygen will be dissolved in water, therefore aquatic animals can survive. In summer season, what happens? Room temperature increases. As the room temperature increases, the dissolution of oxygen will decrease. Then aquatic animals may die due to lack of oxygen, or they will migrate towards other substance, other places where there is winter season. That is the reason of migration of aquatic animals from the area where the summer season takes place towards the area where winter season takes place. What is the summary of it? This is the practical thing. And this dissolution of oxygen, if I write the equation again, and this dissolution and evaporation will be taking place, and I can write the equation now. Here it is a solute is a gas, plus again solvent is liquid, because the gas is solute here, solvent is liquid. So when the saturation is crossed, again there exists an equilibrium, forming a particular solution. Again a solution will be decided by the solvent. This will be in the liquid state. Here also there is an equilibrium system, right? What do you mean by equilibrium system? Means this dissolution and here evaporation. Forward reaction is a dissolution in case of gas and liquid, and backward reaction is evaporation, means from the surface. Evaporation means the dissolution of oxygen in water and evaporation of oxygen in water, or nitrogen and oxygen mainly present in the air, dissolution in oxygen in water, and evaporation of water. So these two factors are taking place simultaneously in opposite direction. There exists an equilibrium, like we studied in case of solid in liquid. Similarly, gas in liquid will have forward reaction will be dissolution, backward reaction will be evaporation. This is forward reaction and backward reaction. So here also, when the equilibrium is attained, you can apply Lee-Chatelier's principle. What happens is, generally dissolution of solute in a solvent will be generally exothermic, means generally heat energy will be liberated. Whenever a gas is dissolved in water, heat energy is liberated. I hope you understood. Means forward reaction will be exothermic. Generally, remember, dissolution of gas in water, any gas, dissolution of gas in water or anything you can take, water, is exothermic. I will explain you why aquatic animals is exothermic. Why aquatic animals do not survive in summer season. What happens is, in winter season, so what is the effect of temperature on the equilibrium system now? If I increase the temperature, because dissolution of most of the gases in a solvent like water, right, is exothermic in nature. Means forward reaction and dissolution is always exothermic. And therefore evaporation will be endothermic. For the evaporation, heat energy should be absorbed, and therefore evaporation is endothermic, plus heat. Backward reaction is plus heat. Backward reaction is minus heat. Forward reaction is plus heat. Means what happens in the winter season, room temperature will be less. What is the factors? Two factors are affecting it. One is this dissolution of a solute and the solvent depends upon different factors. Nature of the gas. Remember, different gases will have different ability to dissolve. And it depends upon nature of solvent, what type of solvent it is. And it also depends mainly on water, temperature and pressure. See, let us take the same example of why aquatic animal die in summer season and they can survive in winter season. They migrate to some other places where there is a winter season, aquatic animals, because at room temperature, and in winter season as a room temperature is low, the dissolution of oxygen in water, see, when the temperature decreases, according to Lee-Chatelier principle, which one will be favored? Just now we discussed. If the temperature is, now it is in equilibrium, already the solution is saturated and it is in equilibrium, according to Lee-Chatelier principle, what happens? According to Lee-Chatelier principle, what the Lee-Chatelier principle states? Lee-Chatelier principle. What the Lee-Chatelier principle tells you? Tells you that a equilibrium state will try to nullify the effect of the decrease in temperature. When the temperature is decreased, equilibrium will shift in such a direction where the heat energy is increased. Therefore, when the temperature decreases, forward reaction is exothermic. Dissolution of gas in water, in particular if you take solvent as water, if you decrease the temperature, as the reaction is forward reaction is exothermic, in order to restore the temperature of equilibrium. Generally, at equilibrium it will have a constant temperature. At a constant temperature, this temperature will be constant at equilibrium. Okay. Now, suppose that it is at equilibrium at 30 degrees centigrade. If I decrease the temperature to about 25 degrees centigrade, what happens? Forward reaction is exothermic. It should the solution should increase. The equilibrium system should increase the temperature to come back to 30 degrees centigrade. Therefore, in order to increase the temperature, exothermic reaction should take place. Exothermic reaction takes place in the forward reaction. Therefore, dissolution is favored or evaporation is favored. In the forward reaction, dissolution is favored. Therefore, dissolution is favored. Dissolution of gas in favored according to Leith-Etler's principle. Therefore, in the winter season, room temperature will be low. Therefore, dissolution of oxygen in water increases. In which season? In which season? Winter season. Because the room temperature is low. Therefore, in order to attain the equilibrium back, according to Leith-Etler's principle, as the forward reaction is exothermic, the reaction will shift to the forward direction. Therefore, dissolution of gas is favored. And if I continue, in the summer season, what happens? Room temperature is increases. Say, room temperature becomes up to 40 degrees centigrade. Already we have in summer season 50 degrees centigrade. Then when the temperature is increased, our system will be at equilibrium, say at 30 degrees centigrade. Now, this temperature should be lost. Therefore, what happens is the dissolved gases, which reaction is favored? See, whatever excess temperature is there, it should be absorbed. In order to absorb it, the equilibrium will shift to backward direction. Means dissolved oxygen means evaporation will be favored. Study it carefully, my dear students. You can understand very easily. Evaporation is favored. So, in which direction evaporation takes place? In the backward direction evaporation takes place. So, therefore, dissolved oxygen in the summer season, as the temperature goes to 40 degrees centigrade, in order to attain the equilibrium will shift in which direction? In the backward direction. Therefore, whatever dissolved oxygen is there, it will be liberated back into atmosphere. As a result, aquatic animals are present in the water, they will be evaporated. As a result, the aquatic animals will feel suffocation. If you do not get excess oxygen, will feel water, suffocation. And hence they may die. Therefore, they will migrate towards some other places where there is winter season. I hope you understood the basic things that you have to remember. So, another factor is called as pressure. Another factor is pressure. We will study this pressure carefully. And this pressure was studied in detail by two chemists. One is Dalton and another is Henry. And here, two chemists, Henry and at the contemporary Dalton, both of them studied effect of pressure on this equilibrium. Solubility of gas in liquid was studied in detail by, effect of pressure was studied by Henry as well as Dalton independently. And what Henry says is that, Henry's law. Suppose that this is again we will take the same case of water, or I will take soda water bottle. Generally, whenever you feel indigestion, you will go and drink the soda. So, what is soda water? Soda water kuditiralla, indigestion adag. Soda water. Yes, good morning, Deepthi. Endothermic reaction, you have doubt when temperature is high. This is temperature is high. You want this to explain again? Not getting? Yes, good morning. When the temperature increases, you not understood. Yes, yes, you can ask in the comment box. Comment box. Answer. Yes, good morning, good morning. Understood this particular concept? Let me repeat you. See, generally you studied when a gas is dissolved in any solvent, the reaction will be exothermic. So therefore, forward reaction will be exothermic. Forward reaction is exothermic. What Lee Chatterjee tells now, whenever equilibrium system is there, if you disturb it, it will again try to attain the equilibrium state. Suppose that our say dissolution of oxygen in water, oxygen gas in water liquid is in equilibrium. Say that is oxygen solution, aqua dissolved in water. This forward reaction liberates heat energy plus heat, or delta H, heat content will be negative. Heat energy is given back to the atmosphere. Right? When you, in the winter season, temperature will be low. Winter season you will feel cold. In rainy season, when the temperature decreases, say it becomes 25 degrees centigrade, means room temperature decreases. Even it goes to negative temperatures also in many places. When the temperature is decreased to 10 degrees centigrade, to restore it, what should happen? From 10 degrees centigrade to 30 degrees centigrade. 30 degrees centigrade temperature should be raised. In order to raise the room, the equilibrium temperature, it will try to attain the equilibrium back. The temperature should be increased. Only way for the equilibrium system is either in the forward direction or in the backward direction. In which direction temperature increases? To increase the temperature, exothermic reaction should take place. Exothermic reaction takes place in the forward direction. Therefore, to increase the temperature, more of the forward reaction takes place. When more forward reaction takes place, more oxygen will be dissolved in water. Are you getting me? Dissolution is favored. When more oxygen is dissolved in water, underwater, aquatic animals will get more oxygen. Therefore, they can comfortably survive. In summer season, room temperature will be 40 degrees centigrade. Or equilibrium wants to be in the water 30 degrees centigrade. When the room temperature is 40 degrees centigrade, now the temperature should be decreased by 10 degrees centigrade. In order to decrease the temperature, right, the forward reaction is exothermic, means backward reaction will be endothermic. Endothermic reaction should take place in order to decrease the temperature. Therefore, equilibrium shifts to backward direction, means from the solution, dissolved gas should what? Evaporate. Therefore, oxygen will be evaporated. Think for it, you can understand it easily. Backward reaction is endothermic. Therefore, in order to decrease the temperature, backward reaction takes place. More it will be endothermic. Endothermic. Backward reaction will be endothermic. Means heat energy will be absorbed. From 40 degrees centigrade to cool it to 30 degrees centigrade. Endothermic means absorption of heat energy. 10 degrees centigrade should be absorbed. In order to absorb it, equilibrium will be shifted to left. What happens? Evaporation is favored. Therefore, dissolved oxygen in water will come out. Therefore, at high temperature or in the summer season, dissolved oxygen in ocean water, river water will be evaporated back into atmosphere. Therefore, aquatic animals living underwater will feel the deficiency of oxygen. Therefore, they feel suffocating. What happens if you do not get much oxygen? You feel suffocation. Therefore, they will die. Therefore, generally aquatic animals will survive in winter season more happily, more comfortably than in summer season. That is one example. And the second effect is effect of pressure. We will try to understand the effect of pressure. Second property, I hope it is clearer to you now. Dissolution of gas in water, effect of temperature. And effect of pressure is another important factor. Backward reaction, I will write here, backward reaction is evaporation. Evaporation is backward reaction. This is backward, this is forward. This is backward. Backward. Okay. Now we will take the example of soda water bottle. What is soda water consists of? Soda water bottle, you just if you open it by using the opener, right? What is soda water? Soda water consists of dissolved carbon dioxide gas in water. What do you observe? Once the bottle is opened, you will observe bubbles coming out. Right? Before opening with the opener, no bubbles are observed. Once the soda water bottle is opened, you can observe, bubbles coming out. Bubbles come out. Why? Why it happens? Generally, in the bottle, what they do is carbon dioxide is filled under pressure. Under pressure, carbon dioxide gas is filled under pressure. As the pressure inside it is very high. Say, what is the pressure of air? Once you open the bottle, pressure will be 1 atmosphere. Are you getting me? Under pressure, it will be dissolved. Means here, say it is compressed to about 10 atmosphere. Means once you open the bottle, the external pressure becomes low, and this carbon dioxide will be in the dissolved state, say when the pressure is say about 3 to 4 atmosphere. If you compress it under high pressure or 4 atmospheric pressure, this carbon dioxide will be in the liquid state. You cannot observe bubble before opening the soda water bottle using opener. You know, you will open it, no? Then the bubbles start coming. Before bubbles start coming, you have to drink it so that whatever gases are formed, they are removed outside. Therefore, you are drinking soda water. Now, why it happens is, external pressure is 1 atmosphere. Internally pressure, carbon dioxide will be in the dissolved state. Now, the reaction is carbon dioxide gas plus water solvent in equilibrium with carbon dioxide, aqua dissolved carbon dioxide. Like oxygen we took, we will take the case of carbon dioxide in soda water bottle. What is the effect of pressure on it? There are no gas molecules on the forward direction, right? Forward direction, there is no pressure. Now, once the pressure becomes 1 atmosphere, the carbon dioxide, dissolved carbon dioxide will come out. This was observed by Henry as well as the Dalton. And they said that the mass of the, what Henry states that the mass of the gas dissolved. The mass of the gas dissolved because air, for example, air if you take, it is a mixture of nitrogen, oxygen, about 70, more than 70% is nitrogen, remaining is oxygen, even carbon dioxide is present in the air, right? If you fill, if once it comes to the atmosphere, the pressure becomes less. At low pressure, carbon dioxide gas cannot be in the dissolved state. Therefore, pressure has effect on the solubility of gas in liquid. Andra, ಈಗ compressed carbon dioxide gas ಇದ್ದಾಗ 4 atmosphere ನೊಳಗೆ carbon dioxide gas dissolved ಇರ್ತದೆ. ಇದನ್ನ ಒಮ್ಮೆ ಓಪನ್ ಮಾಡಿಬಿಟ್ರಿ ಅಂದ್ರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಏರ್ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಎಷ್ಟದ 1 ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅದ. ಅದರ ಪ್ರೆಷರ್ ಸಡನ್ಲಿ ಕಡಿಮೆ ಆಗ್ಬಿಡುತ್ತೆ. ಪ್ರೆಷರ್ ಕಡಿಮೆ ಆದ್ಮೇಲೆ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ 1 ಅಟ್ಮಾಸ್ಫಿಯರ್ನೊಳಗೆ ಡಿಸಾಲ್ವ್ ಆಗೋದಿಲ್ಲ. ಹೀಗಾಗಿ ಬಬಲ್ಸ್ ಹೊರಗೆ ಬಂದ್ಬಿಡ್ತಾವ. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಜನರಲಿ ಗ್ಯಾಸಸ್, the dissolution of gases depends upon the temperature. Higher the temperature, more will be the solubility. Higher the pressure, more will be solubility. Lower the pressure, less will be the solubility. This was observed by Henry as well as Dalton. He says that Henry's law. You can note down the statement of the Henry's law. The same thing Henry stated. He stated that solubility of a gas in a liquid, generally solubility of a gas in a liquid is already exothermic, means this is exothermic. 1 point. Henry's law means for the carbon dioxide to be dissolved. Now here is a gas, there is no gas here. And this is called as, this particular reaction is called as, this is called as the dissolution again. This is called as evaporation of carbon dioxide gas. Once you open the bottle, evaporation takes place. Apply Le-Chatelier's principle. Before you learn Henry's law. What is the Le-Chatelier's principle? Le-Chatelier's principle. See, generally pressure is only for gases, not for water and solid. Remember, liquid and solid have no effect on pressure. But the carbon dioxide is a gas, no? In the reactant side, there is carbon dioxide. In the product side, there is no carbon dioxide. Right? Then according to Le-Chatelier's principle, if you increase the pressure, I will show arrow mark with upward sign. What do you expect? And when you increase the pressure, suppose that this particular equilibrium is at say 2 atmospheric pressure and carbon dioxide, say 4 atmospheric pressure, carbon dioxide is in the equilibrium, say, right? When you increase the pressure, means the number of gaseous molecules are the forward reaction ಅಲ್ಲಿ ಏನಾಗಲಿಕ್ಕತ್ತದ? No, there are no gases. In the forward reaction, there is only dissolved carbon dioxide in the aqueous state. As the pressure is increased, what do you think? Equilibrium dissolution takes place or evaporation takes place? Are you getting me? The same case you can take here. Now our carbon dioxide is in the dissolved state at 4 atmosphere. Means dissolution increases. As the pressure increases, dissolution increases, because whatever excess pressure, now it is at 4, it is the equilibrium is at say 2 atmosphere. When they increase the pressure up to 4 atmosphere to nullify the effect, what should happen? Pressure should decrease. When there are no gases on the products, the equilibrium shift to what direction? Forward direction. Then the pressure will be decreased to 2 atmosphere, equilibrium is attained. Therefore, Henry and Dalton observed that as the pressure increases on a solvent like water, dissolution will be more. What happens when you open the knob of using opener? If you open the knob of the soda water bottle, is suddenly pressure becomes what? 1 atmosphere. Because in the air there is 1 atmosphere. Now the equilibrium pressure is a 2 atmosphere. Then to this particular increase the pressure, do you think backward reaction takes place? Because pressure is increased only when the gas is formed, right? So therefore, evaporation in order to increase from 1 atmosphere to 2 atmosphere, backward reaction should take place. because more and more carbon dioxide should be formed. Therefore, this particular, once you decrease the pressure, open the knob, it is at 4 atmosphere, it is in the dissolved state. In atmospheric pressure is 1 atmosphere. When the pressure is decreased, according to Le-Chatelier's principle, to restore to 2 atmosphere, more evaporation takes place, backward reaction takes place. That is the effect of pressure, because there are no gases here. To get the gas, to increase the pressure, gases should be released. In which direction gases are released? Backward direction. Therefore, decreasing the pressure, more evaporation takes place. Now, what happens is, when you decrease the pressure from soda water bottle, dissolved carbon dioxide, backward reaction takes place, will come out of the water. Therefore, you are observing the bubbles. This is a practical application of the effect of pressure on the water or on the solvent if the solute is a gas. Same was quantitatively studied by Henry as well as Dalton. They stated a law. The law is called as Henry's law. First, to understand application of Le-Chatelier's principle, then you can take the statement of it. That is Henry's law statement. You can note down, very important, Henry's law. Right? The solubility of a gas the solubility statement, you can note down what it states. The solubility of a gas, in a liquid is directly proportional to the, you know what is the meaning of directly proportional? Directly proportional to the partial pressure of the gas, proportional to the partial pressure of the gas, partial pressure of the gas present above the surface, above the surface of solution, at a constant temperature. Very important, at a constant temperature. Remember, temperature should be kept constant at a constant temperature. Remember, this is the statement. You try to let me explain you. Why you can see what is solubility. The solubility of a gas is in a solution. The solubility of a gas in a liquid. You can include in a liquid. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of solution at a constant temperature. Whether temperature should be kept constant. You studied just now. I explained you effect of pressure. What is the effect of temperature on it? First case, first one. What is the effect of temperature? See, dissolution of any gas in water is, just now we discussed, exothermic. Right? If the temperature is increased, what happens? What happens? If the temperature is increased, forward reaction is exothermic. Say, our equilibrium is at 30 degrees centigrade. Carbon dioxide in water is the dissolved state at 30 degrees centigrade. In summer season, if the temperature goes to 40 degrees centigrade, what should happen? Think. When the temperature becomes 40 degrees centigrade, to nullify this effect according to Le-Chatelier principle, temperature should be decreased back into 30 degrees centigrade. Forward reaction and dissolution of gas in water is already exothermic, forward reaction. Then backward reaction will be what? Endothermic. Therefore, in order to absorb the heat energy, endothermic reaction takes place. Therefore, dissolution is favored or evaporation is favored. Backward reaction is evaporation. In order to nullify decrease the temperature by 10 degrees centigrade, backward reaction takes place. Therefore, evaporation is favored. Evaporation is favored. Evaporation is favored. Evaporation is favored. And this is what happens in the summer season. When the temperature increases, already the reaction is exothermic. When the temperature increases, to nullify the effect, dissolved oxygen from the water bodies will evaporate. Hence, aquatic animals feel suffocation. Aquatic animals die. Aquatic animals feel suffocation because feel suffocation, and even they may die also. Therefore, to escape from it, they will migrate to some other place when there is winter. Therefore, that is the effect of temperature. Effect of pressure we discussed, effect of temperature. When the temperature is decreases, in winter season, when the temperature is decreases, it will become 10 degrees centigrade. Now, the equilibrium temperature should be maintained according to Le-Chatelier principle. From 10 degrees centigrade, it should be increased up to what? 30 degrees centigrade. In which direction reaction should take place? Heat energy should be released, should be increased. Therefore, forward reaction takes place. So, therefore, dissolution is favored. Dissolution is favored. And this lowering of the temperature can take place in which season? In winter season. Therefore, in winter season, temperature will go down, say about 10 degrees centigrade. So, therefore, forward reaction should take place. Forward reaction means more of oxygen will be dissolved in it, therefore they can survive. I hope it is clear to you now. And coming back to effect of pressure. What Henry is telling, suppose that it is the water body, say maybe river, maybe lake, or maybe ocean. Okay. So the air will be present in it. Air is a mixture of several gases, nitrogen, oxygen, carbon dioxide will be there. Right? And actually, whenever a mixture of gases are there, there is a law called as the Dalton's law of partial pressure. What do you mean by partial pressure? Partial pressure means part of the pressure. Nitrogen will have some pressure, oxygen will have some pressure, carbon dioxide will have some pressure. Say, partial pressure of oxygen is taken as PA, partial pressure of oxygen or nitrogen is PA, oxygen is PB, and carbon dioxide is PC. Right? This particular partial pressure means a part of the pressure. That is what he is saying. Partial pressure means part of the pressure exerted by oxygen, because air, complete air atmospheric pressure, one atmospheric pressure is distributed among nitrogen, oxygen, carbon dioxide and other gases. Say inert gases. Inert gases are also present in air. Helium, neon, argon are present in air. They also contribute. Means this one atmospheric pressure is the sum of partial pressure of nitrogen, oxygen, carbon dioxide and inert gases. Of that, what is the pressure exhibited by oxygen is considered as partial pressure. Okay. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the solution at a constant temperature. Temperature should be kept constant. If the temperature is not constant, then again equilibrium will be disturbed, because solubility of gas in liquid has got both. I hope you got it. And mathematically you can put it as this particular theory as this particular mass of the solute, means mass of the solute dissolved in aqueous solution is directly proportional to the partial pressure of the gas. Say oxygen gas, partial pressure of the gas, right? And if you remove this proportionality, he will gives it a constant called as Henry's constant. We call it as, whenever you remove proportionality sign, you have to write a constant. This constant is called as Henry's constant. Means quantity of the gas or mass of the gas dissolved in water is directly proportional to partial pressure of the gas at a constant temperature. Is the mathematical form of Henry's law. And Dalton, contemporary of Henry, gave it in a more systematic manner, right? Instead of writing the masses, generally gases are expressed in mole fraction. Means he says that the Dalton's law can be put in a more better way, improvised by Dalton, and he says that at constant temperature, the partial pressure, you can take the more corrected statement by Dalton, at a constant temperature, the partial pressure of a gas, gas in the solution, gas in a vapor phase, partial pressure of the gas in a vapor phase, say it is called as P, is directly proportional to the mole fraction of the gas, directly proportional to, correctly note down the Henry's law, never get confused, directly proportional to mole fraction of the gas, mole fraction of the gas dissolved in a solution. The same Henry's law was reconstructed and reframed by Dalton in a meaningful way, and you can write it as partial pressure is directly proportional to the mole fraction. Mole fraction you studied of the gas dissolved, chi, mole fraction you studied in the beginning. That is P. When you remove the proportionality constant, you will get the KH value, that is called as Henry's constant, where KH is called as Henry's constant. This Henry's constant depends on different factors. What are the factors on which Henry's constant depend? What is vapor pressure? We will discuss in our next period. Okay. So tomorrow, let me clear you again. Tomorrow mathematics test paper will be there. Okay. And today night only I will send the inverse trigonometry function chapter is completed. A 20 marks paper. Tomorrow morning you can write. I will send it tonight today. Okay. And you write it tomorrow at the same time, 6:45 to 7:30, 45 minutes, 20 marks paper will be sent. That is a subjective paper in the board pattern. Then one MCQ question paper is also taken on Sunday, Saturday, if possible, Sunday, if possible, I will come live and I will let you know the timing, because I will be in Gadag. Already the setup is there for a live stream. I will take in the live stream, I will discuss there and try to solve the problem. Inverse trigonometric function, Sunday you can we will have the discussion. Saturday morning you write the test, because I will have morning school, and you also go to the and keep it ready, and don't copy, don't cheat. Let it, you take 0 marks, no problem, but write sincerely, don't copy it. Between 6:45 to, I will send it at 6:45, right? And 45 to 7:30 you write, 45 minutes. Okay, tomorrow and Monday again we will continue with the chemistry, the chapter. Next week I will complete the first chapter solution. This month we have to cover electrochemistry also, right? And remaining part is very quickly covered, no problem. And these are the complicated things. I think I made you clear. If you like our channel and invite your more friends to join live stream, and particularly Puc-Ii, I will be more useful teacher, and I have long experience of training students for Puc-Ii as well as competitive exam. If the concepts are clear, your application skill will be improved. We'll see questions on it, subjective questions for the board, and competitive questions required for the competitive exams in chemistry. Okay, that's all, my dear students, for today. We'll meet tomorrow. Be ready with your answer sheet at 6:45. Sharp at 6:45, I will send you the PDF of the question paper on inverse trigonometric function, sharp at 6:45. You open it at 6:45, start solving it. Okay, bye bye, see you tomorrow. All the best for the first test in LCT, LMT, live, Logzi Live Mathematics Test 1. You write it, and after I will discuss it on Sunday, and you can evaluate on the spot and upload the results in the group. Invite your more friends to come and join and enjoy the classes. If you enjoyed, share with your friends, save the link. Bye bye, see you.